Right, so I'd like to talk now about the data science platform. So following on with our sort of cloud operations and data science functionality. So the data science platform, it's a cloud platform. So I'm going to talk a little bit, just review, I gave a talk yesterday about Wolfram Cloud. I'm just going to review some of the cloud technologies again. We think of these platforms as being very workflow oriented, taking a problem and helping you to go through different steps to solve it. So I'll look at some workflows that we think are useful for data science. I'll look at some of the data computation and data handling functionality that's in Mathematica. And then I'll look at how to deploy and present results with a demonstration of all sorts of things. So the data science platform, I think of it as a Wolfram Cloud that is focused on data science. So it's going to harness Wolfram engine, Wolfram language functions that are good for data science. And in the end, the data science workflow we're going to think of is a load data, compute with data, and then deploy the result. So that's one workflow, but we also need to think about other workflows. For example, how do you create, how do you create the computations or the deployments? So those are workflows that we need to think about. Wolfram Cloud, quick recap. So I gave a talk on this yesterday. Jan just gave a nice talk. Some of the elements of the cloud, we have cloud CDFs, cloud notebooks, exactly what Jan was showing, the nice progress that have been coming out for this in the system. And we have, the idea is there's a user, document lives in the cloud, you can share work with either URL in the browser, there's no installation, and there's just one version of the document, and it can go to different types of devices. It just goes to browsers, so it could be on mobile, for example. Again, when you're running the code, this is a way of setting up cloud callable functions. So these might be functions that are initiated by a user. That's what many of you think of. You type something into a notebook and you do Shift-Enter, but there's all sorts of other ways that are useful for running things. You might have things that run according to a schedule. Every day at midnight, you want to process some data that was collected in the day and then present it. And these are ways that our cloud is very much focused upon supporting these other ways, not just the interactive use, but these other ways of running Wolfram code. So data loading, so the all sorts of ways of loading data into the cloud. And again, you might have what we call a private cloud, a personal cloud, and that will have access to private data. And then maybe a last thing, so I didn't talk about this yesterday, but I'll be talking more about this today, and this is the idea of creating documents under program control. So what this means is you're not typing into the notebook, it's being created for you by a program, and we have a nice way to provide this. So let's think about some workflows that are relevant for data science. So we might think of a data science workflow. We might think of a development workflow. And this might take advantage of some of the nice features of our cloud technology. So one is that our desktop and our cloud versions integrate pretty nicely. So you might start out in a local copy of Mathematica, just sort of prototyping, working in a CDF, a document, making some computations, visualizations. You might store this in the cloud. Of course, you could do the same thing. A user could do the same thing running in the cloud. When you've made some progress with your development, then you might go to a setup phase. So this is where you're taking your initial work and you're going to set it up in the cloud to run. So you might store your code, your notebook templates, data, functions, all sorts of things. You'll store these in the Wolfram cloud. And you can do that from a local copy of Mathematica or from a cloud copy of a cloud account. And then you end up with the sort of final result. So this is really what people are going to be working with, and this is the execution phase, the actual driving of the platform. And so you might have things like data coming from a database. You might be reading from a database and then writing back out to it. You might be loading a notebook template and then generating an output report and then emailing results out to people. There's all sorts of possible ways of doing this. And a really key thing to remember here, this really a key thing, is that this is a server operation. There's no user driving this. This is just happening automatically in a server. And that's what makes it particularly useful. Right. So let's keep going. Now, so the data science platform is another of the platforms that we're building from our cloud technology. And I'm just going to log into this. That's not so encouraging. Now, why is that? Let me just come in here. Just give me a second. Maybe I'll have to. Oh, I know what the problem is. I have to log in first. I should have logged in before I started the talk. So when you log into passwords when you're giving a talk, you always have to be careful you don't type your password into the user field. So I've seen people doing that. And right. So there we go. So that's now I'm going to go back, and it's still not. I think I'm going to. It's kind of annoying. I think it's changed. Right. I apologize because I think this has. Oh, I know. Maybe I'll try one last thing. It's possible that I need to. The data. This is still an emerging technology, and let's just. I'm not going to spend too much time. Make one last attempt. There we go. This is not available. Obviously, I had to have my VPN connection set up because it works. So this is some idea of the home page of the data science platform that you might see. Now, essentially, many of the functions that driving this are Wolfram language functions, and they're similar functions in all of these platforms. What we've done is we've optimized the user interface for data science applications. And so, for example, on the front page here, we've got some data workflows set up. So these things here are particularly set up to support maybe uploading a data file, or let's get rid of cancel, or I'm importing data from a URL. So you would go through these to sort of get started with your work. Many of the elements are kind of similar. So there's like cloud CDS, API functions, and such like, with some new features that I'll be showing you. And just remember that everything I'm showing you, I'm showing you the public cloud, but there's a private cloud version of this as well. So everything that works in the public cloud works in the private cloud. So that's some idea of the sort of portal thing. I'll get to some more demos. But let's look at what Mathematica actually provides for data science. So I'm just going to give some demos, and I need to come back here, and let's come and right. There we go. And when this finishes running, I should have converted. I'm not quite sure why this is taking quite so long to run. And let's do. There we go. That's okay. So I've got a data set here, some data, and it's just some sample set of data that I made up with Mathematica, and I'm going to demonstrate some of the machine learning features of Mathematica. So it's a set of heights and genders, and I'm going to make a picture here. So I'm showing this is the male heights, and this is the sort of female heights. There's like a distribution, and the men are slightly higher. And I'm going to use this obviously a very simple machine learning sort of example, and I'm going to train it on the first 500 people, and that builds this classifier function. And then if I feed in a particular height, it says that 1.79 meters. It thinks this is going to be a man, and we can also get out the probabilities. So that's quite nice. And then, of course, I could feed in get a probability distribution, plot the cumulative, the probabilities. This would be a cumulative probability, or the probabilities as a function of the height. So that's the machine learning. We've seen other talks. People have been using this in much more sophisticated ways, doing image and text processing. This is a more simple use of the data processing. Now, another feature that was added in version 10 is the dataset feature. And this is a nice way to handle structured data that has some sort of structure, not necessarily rectangular data. And it supports queries and computations and such like. So let's just have a little look at this. So here I've got, again, a data set that shows a number of data, and I've got two columns, so an age column and a height column. And I can do things like I can pick out the first element, so I'm going to the first row, and I'm saying give me the height. Or I could say pick out all of the rows, give me the height value. So this is kind of one way to hold data. Now the nice thing about this is I can do queries on it. So I can do, for example, show me all the rows with age greater than 25. And that picks this out. Or I could select the reason I put the normal there is what I'm going to do is select all the ages greater than 25 and just show me the height. And normally this will also return a data set. So if I want just the raw numbers, then I enter it like this. What's this? So that's the using the data set. Now I can also apply a function to a whole data set or a particular column. So here I'm applying mean, and it applies the mean to the age column and the height column. So that gives me the things there. Or here I can get another sort of nice aggregation of all of the data, and I'm getting the, making a plot, or I could put in things like, like this. And that's pretty convenient way of working with data to sort of hold it and make plots. Here's another example. This is using a sort of, another thing like a sort of database functionality. I've got two tables of data, and I want to sort of combine them in a way so that I join things for which this sort of ID column is equal. So in SQL language, this would be a join, and I can do this with the join across with the join across function. So I apply that to the two data sets, and I say I want to combine them for where the ID is equal, or I could then do that and then sort by the ID, or I could sort by the floors. So this is a nice way to work with data and do queries and handle them. And this is something that we're developing as more versions come out, and we'll be looking to build special optimized versions and versions where the data really is coming from an SQL database, or versions where the data is very large and lives in a file on your, a sort of a file. It's not resident in memory all at the same time. So that's data set. Another system that we added in version 10, I think, was a nice time series functionality. And so this is a way of working with data that has a time element to it. And I've got a basic sort of set of data. These are measurements of some stock market thing that over a few years. And I can do all sorts of, nice, it knows about time. So I could do something where, I take do some sort of smoothing. So I'm going to do, calculate the mean, move a mean over 10-day periods, and it takes care of, if the data's not, sort of uniformly spaced and things like that. Now, one of the things that's some nice things about these time series is some very basic things that I very often see people when they use Mathematica. Like they make plots of data, where one of the elements is time, but they don't, the axes, they just put sort of, integers or something. It's much more powerful when you're making visualizations to actually put, these are like years. So you want to show the years that they represent. So it's a very nice, convenient workflow for producing good plots like that. And here's another useful feature that, I've seen people and they write quite a lot of code. And what they have is they've got two different data sets covering different time periods, and they want to combine them in some way, in some meaningful way. And so the time series set of functions has a nice feature called time series insert, which is sort of joining the two things and making a composite time series. So I've gone, this one goes from 2006 to the middle of 2008, and this goes from 2008 through to 2015. And when I do the insert operation, it's combined them in some sort of useful way. So these sorts of functionalities are tremendously powerful and will save you a lot of time. And there's other useful features in the time series set of functions for rescaling and shifting. These really save you a lot of effort. And the time series in particular, it's very optimized, so it's fast for these operations, and it's very efficient at holding your data. So that's the time series computations. I'm not really going to give you a big demo of this, but we've been working over many versions of Mathematica to enhance the statistical computation features. So you can take some data and you can extract various information from it, various statistical distributions, and we have a very powerful statistics set of functions that is really optimized and a large set of functionality with computations and then all sorts of special plots and so on. And this uses all sorts of other features of Mathematica, such as the optimization functionality to do parameter estimation, for example. And this is something that over the years, a lot of users of Mathematica have become particularly interested in, and the data science platform is now making it able to use these things in a wider set of, in more sort of ways. Now, another data relevant piece of functionality that we've added is this thing that we call data drop. So this is built on top of our cloud. So you've seen people talking about API functions and things like that. So this is a data-centric data aggregation service that we've added. And it's based upon these things that we call data bins. So I'm just loading a little data bin. So this is coming from the cloud. So you set up one of these bins, and then you can sort of add data to it as you go along. So this is really a time series aggregation of data. So you're sort of adding data as time goes along. I can see all the values of the data in the data bin, and I could make a list plot of them. And then there are things like data bin add. If I wanted to add more data to the data bin, then this is a web function, so it's going off to the cloud. And now this data bin has 51 elements, whereas I must. Right, I've already added that data point previously. But this is a pretty useful function for working with data, and there's all sorts of ways of accessing this data. So I can go to the web, to the data drop website, and when this opens up, it's going to give me some summary of this particular set of data. And I can work with it in Wolfram Alpha, for example, and it's giving me some sort of information about it. So you can work with this in a bunch of different ways. So that's data drop. Data drop also in private clouds, you can have a private version of data drop. Okay, now I want to talk about report generation. So we've had data, we've loaded data maybe from data drop, we've done computation with it. Now we want to produce some sort of output summary of the information that people could look at and use. And the report generation is a way that we've developed. So it's based upon template notebooks. So I'm going to let's come and. So I come and add various little sort of add markup in the and I'm going to do so I've made a basic template like this. A quick way that's pretty handy is there's this sort of generate button that's a quick preview type of thing, but I can also just come and execute the report with this generate document function. Oh, I'm typing too quickly. I didn't finish, close there we go. So let's come and rerun this. So then I would prepare the data and then execute the report, and then I've created, so this is a way of creating a new notebook, but without having to sort of insert all the details. So we've got more examples of this. Here's one that is based upon a more elaborate one, and this is going to load some financial data. So this is a sample example that we have, and this is running. It's loading some financial data using our financial data feeds that we have, the basic financial data system that we have. And so I've created a dynamic, a report output here. But what's nice about report generation in Mathematica is this is a CDF. So it's not like a static, dead document. It's an interactive thing that I can that I can sort of work with in other ways that I can work with CDF. So, and then here's another example that I kind of like, that Anthony put this together. And so this is a way of closing the gap on his classifier. So remember, his machine learning, it had a nice machine learning example where he was processing reviews on the Amazon website, and then he built this little micro site here. And you can type in, the idea is you type in the name of an actor, and it runs the thing, and it creates, so this is in the browser, and it's creating a cloud CDF output with the, that we see here, and this is coming and seeing here what we've put together here. And this is showing how his classifier compares with the actual reviews that are put together. So this is another sort of use of notebook templating, but this is one that's running in the web. Given the time constraints, I'm not going to spend all my time. Wait for it to complete. In the data science platform, a thing that's useful is to take this templating system and run it in, sort of in the data science platform. And here's another example that one might imagine, where I take a template, and then I'm going to insert data in it to make some sort of schedule for something. So I can now come and deploy this to the web. So I'm pushing the template up to the web, and I'm going to push the data up to the web. And now what I'm going to do is another cloud deploy, where I'm deploying a thing we call the document generator. And the document generator is a complete workflow, a complete wrapping of document, a template. There's a driver to generate the to generate the data that's going to be inserted into the document, and then some things like to set up a notification. And then I can run this thing either. Now I set this to run when I'm asking it to run. So I've set up this run scheduled task thing here, and then if I come and look at my email, given the time constraints, I'm just going to show you what happens is I get emailed to me a report that tells me that this computation has run in the cloud. It emails out the results, and that's a pretty nice workflow to process data and utilize Mathematica computations in the web. Right. We can also take this, obviously we can run it on a time schedule, and there's a UI for setting up the schedules as well. And the output of these documents, obviously Cloud CDF's pretty appealing. It's very easy to send, but we can convert into PDF or static web pages, and it's very customizable. So I'll just summarize, and then we can end. Data science platform. It's a workflow. It's designed to optimize data science workflows, taking data science functions from the Wolfram language. It makes use of the sort of desktop cloud hybridization features that we have, and it takes advantage of a lot of cloud benefits like zero configuration and such like, but we also get in a private cloud, you could get sort of privacy and scalability, and it's, again, very much focused on this sort of execute workflow, driven in the cloud, providing data processing, using data computation features of the Wolfram language. So thank you very much.